Hey, so today we are going to talk about 11.3 and one of the more important statistical models that we have in the world. It's called a normal distribution curve, or a normal curve. And the reason that we like the normal curve so much is that it finds a way to represent just really common data. Things that are we would use to model like the height of individuals in a country or in a state. You might say that it models test scores. If you take standard deviations and averages of tests for like an SAT or an ACT or an ISAT, you'd expect those scores to follow the normal distribution. And here are some of the characteristics we'd want to focus on. Right in the middle is our average, and there's a huge chunk of people, 68% of people, who are pretty close to the average, or pretty close to the normal. And as you get closer and closer out here to where you're really pretty far from normal, there's a very small percentage, only 0.15%, that's more than 3 standard deviations away from the mean. And it's balanced, it's uniform on both sides. So this is on page 757. We're going to refer to this page a couple more times. Remember that this Greek letter sigma, that funny looking circle right there, it stands for the standard deviation. So we need to know how much the standard deviation is for a data set. And that x with the bar over the top, again, is our mean. The other thing that we're going to have to do is calculate a couple of things. Okay, I'm going to move you around here real quick. Okay, so right here, one of the things that we're going to have to do is figure out how many standard deviations away are we from the average. And the way that we calculate that is by taking the number we have, our value that we're looking at, minus the average. Now sometimes that'll come out negative, meaning that we're on the left of the average. Sometimes it'll come out positive, meaning we're on the right of the average. And then we divide it by the standard deviation. What this will tell us, it's called a z-score. It'll tell us how many standard deviations we are away from the middle. If we're 1.5 standard deviations away, that would mean that we're in this region here. And we could determine what the probability of being in that region is. Like what percentage of people fit over there in that area. And so we want to be able to make those assumptions or make those decisions about things that aren't exactly 1 standard deviation or exactly 2 standard deviations away. And so when we have that, we have what's called the standard normal table. And this is where we actually read the z-scores. Now it's important you understand how to read these. We can start with a -3, -2, -1, 0, 0, 1, 2, and 3. And then let's say that we had the number 1.4. Well, we would start here with 1, and we would slide over to 0.4. And if you are 1.4 standard deviations above the average, because it's positive, so you're bigger than the average, you would say that you are in the 91.92 percentile, meaning that 91.92% of people are below that point. Okay, so that allows us to figure out how many people or how likely is a specific value. Okay, so we're going to look at some example problems, and we're going to have to flip back and forth with this quite a few times. Okay, so first thing we're going to do is we are going to look at these probabilities when we're looking at some basic probabilities where we do have a solid number of standard deviations. So we're actually going to look at question number 6 here. Actually, we're going to look at 7. Okay, and it says that the probability that x, our mean minus 1 standard deviation, is less than or equal to x is less than or equal to x bar, or average, plus 1 standard deviation. Okay, so I've got that written down. Let's transfer over a couple of pages. Here we go. All right, so we have, just so we're clear on how to read this, this is the average, and we're saying less by 1 standard deviation. So this is 1 standard deviation less than the average. So if I'm thinking about my normal distribution curve, okay, whoops, that wasn't drawn very well. Okay, here's my average. 1 standard deviation is 1 line to the left or right. And since this is minus, I'm going to come one line to the left. Okay, that's my average minus one standard deviation. And then over here, this is x plus one standard deviation, which would be the next line to the right. X bar plus one standard deviation. Now, notice that x right here is sitting between those. So what the question's asking is, what's the probability that you would fit between those two values? Okay, so we're asking, what's the area underneath this curve? How much area fills up that space? Well, if I come back to the text and we take a quick look at our data table here, we see that from the average to one standard deviation to the right, it's 34% of people. And one standard deviation to the left, it's also 34% people. Meaning that this region here is 68% of people. Now this is really important that we understand that 68% of people fit in that category. If I'm looking at selling a product or making sure that people have adequate needs, adequate support for their needs, 68% of the people are going to basically be average. And so most people are going to be satisfied by that. But I also have to acknowledge that 32% of people don't fit that. So almost a third of the population isn't going to be satisfied by what we would call normal. We have to consider those people and how do we satisfy, the needs that they have and make sure that we're being careful there. So this first part of the assignment is really about reading the table that you find on page 757, which is right here. Figuring out where are we looking at, and let's add those percentages up. Okay, it's going to change a little bit when we go to the next section of the homework, if we go to I probably ought to just open up a text that I can look at. If we go back to the problems and we look at, say, question number, let's say question number 15. Okay, so 15 is going to change on us a little bit. Okay, we want the probability of being at least 29. Now, they gave us some data information in the problems above. So we really have to think about these data sets and this information. It says that the mean, okay, so the mean is 33, and they tell us that a standard deviation in this problem is 4. Okay? Now, what we have to understand is we come back to drawing our normal distribution curve, something like that, right? Here's our 33. Now, where would 29 be? That's the question. This first set's going to be pretty easy because it's going to be whole numbers of standard deviations. 29 would be one standard deviation, or 4, less than 33. So if I come back over here to 29, that's really the average minus a standard deviation. Now, because we have the average of 30 minus one standard deviation, 4, this should line up with my picture, which I'm going to show you again right up here. If this is 33, this would be 29. Okay, so you got to think this line right here, if I have 50% right in the center, there's 34% there. So I'm going to come back and I'm going to draw this real quick. This is 50%, okay? This region here is 34%. Now, when I say 50%, what I mean is that 50% is to the left. Okay? Now, the question was, what's the probability of being at least 29? Now, you have to think that that means you want to be bigger than 29. So that would mean that I don't want any of this region out here. That's garbage. What I want is all of this, but I also want all of this. So based on that information, what percentage of people or what area exists over here to the right of my number 29? Well, we know it takes 34 to get to here. This region here is 34%. And we also know that from the center, or from the average, over to the far edge, if you kept going forever, you would get 50%. So that gives us a total, or a probability, of 84%. Again, now that's a much better return on who you're investing in than just getting 68%. By extending to the upper end, I now have increased it to where I'm only ignoring really 16% of the population. Now that 16% might be a really important part of the percentage of people, but it I've got less concern. Now those have been nice because they're easy, even numbers. Like if we had said at least 28, well, that wouldn't line up on a standard deviation line. It'd be off a little bit, and it would be a lot harder to work with. We're going to look at how those problems are structured a little bit differently in the next question. So what we're going to do is we're going to look at question number 26. Okay. So 26 is going to give me some specific information about the average, or the mean. It tells me in the problem above that the mean is 64. And the standard deviation is 7. And now we want to know the probability of being between 60 and 75. Alright, so I'm going to start by drawing a quick sketch of the normal distribution. I really want to know kind of what I'm looking at here, okay? So here's my mean of 64. Over here somewhere is 60, and over here somewhere would be 75. Now this is important. The lines I drew are not exactly one standard deviation away. This is only a gap of 4, which is not a standard deviation that's 7. And this gap here is a gap of 11. Also not a standard deviation of 7. So what this means is, because it's not a whole number, if I had a difference of 7 or 14 or 21, I could just go straight to that graph. Because it's not exactly the same interval as my standard deviation, I'm going to have to come up with a z-score. Now what I'm going to do is I need one for each of my two numbers. So I'm going to do z60 and I'm going to do z75. Now, you may or may not remember the formula for that. It was your number minus the average divided by the standard deviation. So I'll write that down up here again. Z score equals x, that's you, minus the average, or the mean, divided by the standard deviation. So we're going to do that same thing right here. We're going to take our value of 60 minus 64 and then divide that by 7. And here we'll do it again. 75 minus 64 over 7. And we want these to be rounded to one decimal place. So I need to minimize that for just a second. We're going to grab our calculator here and we're going to go 60 minus 64. That's obviously negative 4, and we divide that by 7 to get negative 0.57. So I'm going to write that right up here. Negative 0.57. Okay. This is roughly, I'm going to say negative 0.6. I've got to round it to just one decimal place for the table we're using. There are tables out there that are more accurate, but we're going to deal with one decimal accuracy here. And then if I do the 75 minus 64, it's obviously 11 divided by 7 is 1.57 or 1.6. Okay. Those values tell me how far I am from the standard deviation. Now, I'm going to have to use what's called the z-table, or the normal distribution table. Okay. Standard normal table is how it's titled here. Okay. Let's go ahead and go big again here. Okay. So we have to understand about reading this table is, again, this first value is negative 0.6. So I have to realize that when I do the 0, I have to use the negative side. Okay, so negative 0, and if I slide all the way out to 0.6, I get 0.2743. So that's 0.2743. Okay, let's keep that number handy, okay? And then if I do the same thing with the 1.6, I'll slide right up there. 1.6 is right here, 0.9452. 0.9542. Now we have to understand what these mean. These percentages from the standard normal table tell me what percent of people fall to the left of that number, or the left of that line. So since this was where my 60 is, and the number associated to that is 0.2743, I can say that 0.2743 is the probability of being to the left of that value. Okay? That's what goes on over there. Now, I'm going to grab another pen. I need a second color in here. Now, with the 75, okay, it has a z-score, or it has a value that we're going to use of 0.9542. Now that goes all the way over to there, all the way to the end, but includes a bigger region. So now if I really want to know what is the probability of being in this region right here, okay, what I need to do is take my red value and subtract that smaller blue value. Essentially, I need to cut that piece off of my distribution table. So I'm going to take 0.9542 and I'm going to subtract 0.2743. Now remember, these are decimal versions of percentages. So that's really like 95% and 27%. But if I take my 0.9542 and I subtract 0.2743, I get 0.6799. Okay, that's my probability. You could say that that's the same as a 67.99% chance that you're going to live in this region between those if the average is 64 and the standard deviation is 7. That would be an example of how to use that. This can tell us everything from, when you should expect what you should expect your grade to be, or what you should expect your height to be when you grow to an adulthood. You could also use this as a way to modify or model when you expect people to die. Some people, a lot of people, die at a specific age or around a very specific age. We have a life expectancy. But there are people who die at very young ages, and there are people who die at very old ages. But the longer they live, the less likely it is. And so, we look over and over again. This is a great model for modeling a lot of different information, a lot of different data. So hopefully that's enough to help you make your way through the homework, and we'll see you in class.